Hey class, in today's lesson we're going to talk about solving trigonometric equations, which is found in section 5.3 part 2. Our objective is to solve trigonometric equations of quadratic type. So in example 5, we're asked to find the solutions of the equations on the interval between 0 and 2 pi. So these are, as was mentioned, these are already in the quadratic type. So if they're already kind of set up as a quadratic, the only thing that we have to do is use the substitution method. So what I need to recognize is that throughout this problem, that there are sine x's. So I want to substitute and say that every time I see a sine x, I'm going to write an x. So let's write everything in terms of sine. So what I see is 2 times sine squared x, sine x that has been squared, minus a sine x, minus 1 equals 0. And again, for every sine x, I'm going to put an x. So now this really becomes 2x squared minus x minus 1 equal to 0. Now with AC method, AC is going to give us -2, and the factors of -2 that give us -1 are -2 and positive 1. So I would get 2x squared minus 2x plus x minus 1 equal to 0. If I group and group, I can take a 2x out, and I'm left with x minus 1. On the second one, if I factor out a positive 1, I still have an x minus 1 left over. So that will leave me as factors 2x plus 1 and then x minus 1 that are equal to 0. And that's as far as I can go with them as being just x's, right? So from here now, I need to trade them back out with sine functions, so that 2x plus 1 equal to 0 is now 2 times sine x plus 1 equal to 0. And on the other side, that x minus 1 equal to 0, right? This x minus 1 is now sine x minus 1 equal to 0. And then we solve for x. So let's do the first one. If I subtract 1 on both sides, I would have 2 sine x equal to -1. If I divide by 2, it would be that sine of x equals -1/2. Well, first of all, sine is negative in the third and fourth quadrants. It is negative in the third and fourth quadrants. And again, using our shortcut, we know that sine of 30 is 1/2. So again, it still falls to be true that we're still talking about a 30-degree reference angle, just that the 30-degree reference angle in the third quadrant is 30 degrees past 180, which is 210 degrees, and then 30 degrees before 360, which is 330. As far as radians go, that would be 7 pi over 6 and 11 pi over 6. Okay, so those are my solutions for that half, and I should say x equals that. Okay, and then on the other side, I would need to add 1, because I'm not done with my solutions. Add 1, and I have sine of x equals 1. Well, where is sine 1? Where is sine 1? Well, first of all, sine is your y value, and the only place where y is 1 is at pi over 2, because that order pair is 0. Excuse me. Actually, I think I just stated that wrong. Sine is your y value. Oh, I just wrote it wrong. Okay, sorry. Sine is a y value, and so this order pair is 0, 1. And so at the 90-degree angle, so x is going to be 90 degrees, or you can say pi over 2. All right, and that's all for this example. Let's look at the next question. All right, for 2 sine squared x plus 3 cosine x minus 3 equals 0, the issue here is that we have differing types of trig functions going on. And so it would be preferential if we get everything in terms of the same trig function. So what I see is I see a sine squared, and I also see a cosine. So what I would rather prefer to do, since sine and cosine are related with the Pythagorean identity, I would rather get everything in terms of cosine x, because I can't change that one, right? So then what you need to understand then is sine squared x as a trig identity is really 1 minus cosine squared x. And we could prove that with the Pythagorean identity, but again, I would just say reference your Pythagorean identities, which would show you that sine squared x plus cosine squared x equals 1. Okay, so then that becomes, if I distribute my 2, that becomes 2 minus 2 cosine squared x plus 3 cosine x minus 3 equal to 0. Okay, if we combine like terms, that would give me negative 2 cosine squared x plus 3 cosine x minus 1 equal to 0. And I got minus 1 because I combined positive 2 and negative 3 to give me positive 1. I don't really like to start the AC process off with a negative a value, so I'm going to divide this whole thing by negative 1. So I'll rewrite it as 2 cosine squared x minus 3 cosine x plus 1 equal to 0. Okay, so from there, I need to refer and say that every time I see a cosine x, I'm going to write an x. So that's going to look like 2x squared minus 3x plus 1 equal to 0. If I do AC, my AC value is going to be 2, but the factors of 2 that give me 3 are positive 1 and positive 2. But in this case, the ones that work are going to be negative 1 and I'm going to say negative 1 and negative 2. So this will be 2x squared minus 2x minus x plus 1 equal to 0. So out of the first half, the greatest common factor will be 2x. I'm moving all my work up here. So I factor out a 2x and I'm left with x minus 1. For the second half, if I factor out a negative 1, I'm still left with x minus 1 equal to 0. So then I have 2x minus 1 and x minus 1 equal to 0. Now, of those two, now I need to go back and trade it back out for cosine. So I'm going to switch that to a different color. So this one I'm going to put on the other side. So that's going to be 2 cosine x minus 1 equal to 0. So if I add 1, I get 2 cosine x equal to 1. If I divide that by 2, I get cosine of x equal to 1/2. All right, so think about it. Where is cosine positive? Cosine is only positive in the first and fourth quadrant. And if I think about cosine, if you can't reference it, I would draw it out, right? Cosine is adjacent over hypotenuse, so the adjacent would be 1. The hypotenuse is 2. So that must mean that this side is a square root of 3, which means that my reference angle is a 60-degree angle. So a 60-degree angle in quadrant 1 would actually be 60 degrees, but a 60-degree reference angle in quadrant 4 would be 300 degrees. If I have changed those to radians, that would be pi over 3 and 5 pi over 3. Okay, so those are our first couple of answers. Looking over here where I have the x minus 1, if I set that as cosine of x minus 1 equal to 0, add 1 to both sides, I would get cosine of x equal to 1. So think about it. Where is cosine or your x value 1? Where your x value is only positive 1 at 0. So x equals 0 degrees or 0 radians. And that's it. Let's take a look at our last example. So again, we're supposed to find all the solutions. And here we want to change them. Now it's actually telling us to change it to a quadratic type. So here again, I have differing trig functions, but the only way to get them to be able to solve or get it to where I am able to solve it is if they are in a quadratic form. So to force the quadratic, I'm going to square both sides of my equation. Cosine x plus 1, you can do the box, right? You can do the box to figure that out. So it'd be cosine x and 1, cosine x and 1. That gives you cosine squared x, cosine x, cosine x, and then 1. So on the left-hand side, I have cosine squared x plus 2 cosine x plus 1. And on the right-hand side, I just have sine squared x. But if I want everything in terms of just one variable, you want to decide that based off of the trig function that's not squared. And the trig function that's not squared is cosine x. So I need to change this sine squared x in terms of cosine squared. And we've already stated before that sine squared is the same thing as 1 minus cosine squared x. So if I rewrite this, then it becomes cosine squared x plus 2 cosine x plus 1 equal to 1 minus cosine squared. Don't know what happened. Okay, so I want to move the right-hand side to the left-hand side, so I'm going to subtract 1 and add cosine squared x. Again, subtract 1 and add cosine squared x. Oops, I put it in the wrong spot. Okay, that cancels, and I'm left with a cosine squared plus a cosine squared is 2 cosine squareds plus 2 cosine x equal to 0. Okay, the greatest common factor out of that situation is 2 cosine x. So if I factor out 2 cosine x, I'm left with a cosine x plus 1 equal to 0. All right, in that situation, I want to set both factors equal to 0. So for the first one, if I set 2 cosine x equal to 0 and divide by 2, I'm really looking for the angle when cosine is 0. Cosine is your x value, and so cosine is 0 at pi over 2 and at negative pi over 2 or 3 pi over 2. So I'm going to say, as far as degrees go, that that's either 90 degrees and 270 degrees, or if you want to write it in radians, that'd be pi over 2 and 3 pi over 2. So that's the first half of my answers. If I take this cosine x plus 1 and set that equal to 0, I would subtract 1 on both sides, and I would have cosine x equal to negative 1. Okay, where is cosine negative 1? Well, cosine is negative 1 only in one location, and that is at pi. So x equals 180 degrees or pi. And that is it for now, guys. If you have any questions, again, please be sure to come see me for tutoring.